these are inequalities. And so we're going to be graphing them on the number line and writing our answer in interval notation. So let's look at question 3 from your homework. And what we've got for question 3 is we've got 9x plus 6 over 8 is less than 22 over 3. Now, how would we handle this question? Well, if this would have been an equation, right, we would cross multiply. We do the same technique here. Just like an equation, we're going to go ahead and cross multiply here. So when we cross multiply, we get 3 times 9x plus 6. Inequality symbol stays the same. And then the right-hand side is going to be 8 times that 22. Okay. So does everyone see how we cleared that out? Just simply cross multiply. Now, the inequality symbol stayed the same because when does it flip around? It flips around whenever we do what? Whenever we divide or multiply by a negative, right? We didn't do that here. Okay. So now we distribute and we can finish it. So we'll distribute that 3 through. And then we'll multiply on the right. So 3 times 9, that makes it your 27x there. 3 times 6, that makes it an 18. And 22 times 8, that makes it a 176. Move that 18 over with subtraction. 27x is now less than. We've got 176. We're going to take away 18. So that leaves you with a 158. And we'll divide that by our 27. And always check to see if it reduces. Now, I don't think that it will, because 27 has 3's in it. So let's see if 156 has 3's in it. We divide 156 by 3. It doesn't evenly go in there, so it's not going to reduce down any. Inequality symbol stays the same, and that's 158 over 27. Now we have one more step to do. We now need to put this on our number line. So we draw our number line, and we'll find our 158 over 27. Now we look at the way it points. Here's how you know which way to go, which way to shade. Which way does it point? Okay. It points towards the x, pointing to the left. So where do we shade? We shade to the left. Now, do we use a bracket or parentheses here? Which one? Can someone tell me? Bracket or parentheses? Parentheses, okay? Make sure you know that. Why do we use parentheses? Because strictly less than, strictly greater than, those get parentheses. Greater than or equal to, less than or equal to, those are going to get our brackets, right? So remember that. And if it goes back to the left, it goes back to negative infinity. Now we need to write our answer in what is called interval notation, and it comes directly off the number line. So negative infinity with parentheses, comma, 158 over 27, also with what? Also with parentheses. So there's going to be your answer on that. And I picked that one just so you can see how to clear the fractions out. 7, I picked it because we're going to have to flip our inequality symbols. Okay, so on this one, now this is called a 3-part inequality, right? Now, when do we switch our inequality symbols? Okay, remember, we switch our inequality symbols when we divide or multiply by a negative. We're going to have to do that in this case, and that's going to switch them both and change the order on the number line as well. So the first thing we do is we get that 4x by itself in the middle. So move that 1 over, and that leaves you with 2 minus 1, that's a 1. We have a minus 4x in the middle, And on the other side, we have a 9. Now, this one, we need to make sure we're careful because we're going to be dividing by what now? Negative 4. Okay, and if we divide by a negative number, what happens to our inequality symbols? They reverse, don't they? So that's going to reverse them. So that means x is in the middle. We'll switch our signs around here. And this on the left is going to be a negative 1/4. The right is a negative 9/4. Now, when you put them on the number line, make sure that they are in the correct order. Notice we switched the inequality symbols, right? And which one's smaller? Negative 9/4 is a smaller number, so it's on the left. So make sure you put them in the right order. So negative 9/4 goes here. The negative 1/4 goes over here. And let's talk about the symbols. At negative 9/4, what does it get? Parentheses or brackets now? Okay, negative 9/4, it gets the square brackets. The negative 1/4, what does it get? It gets our parentheses. Our answer's in the middle. And so in terms of interval notation, that would now be negative 9/4, comma, negative 1/4 with parentheses there. Okay. But is everyone all right with how I switched them around? Be very, very careful on these. Now, when you have that double inequality and you switch your inequality symbols, you also switch the order they're on the number line, right? Because make sure you remember, always double check. The smaller number goes on the left. So negative 9/4 is a smaller number, so it's on the further left. Negative 1/4 is bigger, so it's on the right. So make sure you double check them and put them in the correct order in relationship to 0. Did we have any others to look at? Okay, there's not that many of them left. I think you'll find this section to be easy compared to the others. I worked out the applications, 8, 9, and 10 for you. Remember, I set those up so you can finish them on your own. If not, then we'll move on to the next section. And the next section, we're going to be looking at compound inequalities. And this is 1.6. Now, when we talk about compound inequalities, we have to look at and ors and what they mean. So we've got and or. When we talk about these. Now, the and is also called the intersection. And when we talk about the intersection, this is going to be where they overlap. So this is going to be where the graphs overlap. Or is called a union. And a union is, remember, like a marriage where everything gets united together. So when we talk about an or, that's a union. And that means we're going to combine the graphs. So an and is an intersection, and an or is a union. And we're going to be looking at where they overlap, what they have in common. Or is a union, so we're going to be combining them together. Now I'm going to give you some inequalities. We're going to do some ands and some ors. And then once we get these down, then we'll learn how to solve some more of them. So let's just look at some very basic ones. So all we're going to do on these is we're just going to graph them. So let's say I give you x is greater than or equal to 9, and x is less than 15. Okay, so we are going to put these together. Now, when I talk about the and means both. What they have in common, okay, where they overlap at. So I'm going to put these on the same number line, and we're going to use different colors to represent them. So I'm going to graph the first one here in blue. So this one says that x is greater than or equal to 9. So what would that look like on the number line? Well, on the number line, here's my 9. It points to the right. It is greater than or equal to, so it gets a square bracket, and it's going to go out in that direction, isn't it? What about the other one? The other one is x is less than 15. So here would be your 15. And x is less than 15. It's pointing to the left, so we're going to shade to the left here. Now, what does the and mean? And means where they overlap each other. And where is it in both of the graphs? Okay, overlap, or whether it's in both. Where it is in both is going to be right here in the middle. And what would that be? In interval notations, where they overlap. And they overlap from 9 with square brackets to what? To 15 with parentheses. So that would be your answer in interval notation there. Okay. You graph them, and you see where they overlap. Now, what happens if they don't overlap at all? Okay, here's another one. This can also happen. We're going to graph this one. How about x is greater than 12 and x is less than 3? Well, what's going to happen with this one? We have an and again, what does and mean? And means intersection. So let's graph both of these. So this one says, we'll do the first one in blue, x is greater than 12. So what would that look like? Okay, here's my 12, and it is pointing to the right, parentheses, so it's going to look like that. Want it? Okay. Is everyone okay with that so far? Now, what about the other one? Well, the other one is x is less than 3. So what would that one look like? Well, if x is less than 3, that means that I'm going to be shading back to the left like that. Now, the and is where they overlap. Do these ever overlap or cross each other? No. So they never overlap. So what would your solution be? Your solution would be the empty or the null set. Why is it like that? Because they never cross, they never overlap. So they never overlap or cross. So what does and mean? The and means both. And so we're going to be looking at where they cross each other, where they intersect. It's also called an intersection. If they never cross, then they have no solution. Now, what about or? Okay. Or means union. And that's going to be combining them together. So we're going to look at the ors next here. So let's look at this one. About x is greater than 8. Or x is less than or equal to 3. So what's different about this one? Okay, well, this one has an or. And what does or mean? Well, or means union. Right? So we're going to be uniting the pieces together. So they go together, they combine together. So we're going to put these on a number line, and then I'm going to show you how to write your answer. So here we are on the number line, and the first one is x is greater than 8. So we'll find our 8 here. And it is going to have what? Brackets or parentheses for this 8. Which one? This one's going to have parentheses, right? Make sure you're careful there. So the 8 gets parentheses. It's pointing to the right. So it looks like that, doesn't it? What about the 3? Okay. Here's our 3 back here behind it. It gets what? Brackets or parentheses now. It's going to get square brackets, one. Okay. And which way is it pointing? It's pointing to the left, so we're going to shade to the left here. Now, this is negative infinity to the left, and this is positive infinity to the right. How do we combine these together? Well, here's how we write our answer. This is an or, which means union. We're uniting the pieces together. So we start off with each one. So we have a minus infinity to 3 with the square bracket. We also have 8 to infinity. And how do we put the pieces together? We use a U for union. So there's your answer in what is called interval notation. So whenever we put the U, that means we're kind of adding them together. They're sets, so we can't use an addition symbol, and what we use is that U, and that U represents the union. Now, let's look at something that has an infinite number of solutions. So let's try and graph this one. And again, what does the or mean? Or means union. What does this look like when we go to graph them? We draw our number line again. And this one says x is less than or equal to 9. So we find our 9. And we want square bracket. And which way does it point? It points to the left. So that's the way we go. What about the other one? The other one says x is greater than or equal to 2. So that's over here. We'll use square brackets. Remember, this is negative infinity, and this is positive infinity. Now, what happens if I put them together? Okay, if I put these together, what does it do? If I put these together, what does that cover? That covers the entire line, doesn't it? Right? If I put them together. Because what does or mean? Or means you put them together. You unite the pieces together. So if I unite those together, what is it going to do? It's going to cover the entire line. So that would look like negative to positive infinity there. Does it make sense? Why? Because, look at this. Here's the blue line here. Here's the green line over here, right? If I put them together, what does it do? It covers the entire part, right? So that makes it then what? Negative to positive infinity, because it covers the entire part. If it was an and, if this would have been an and, the and would mean here, right in the middle. Okay, and means intersection, where they overlap. So an and would be here, or, which is what we've got here, would be the entire part. So those are the 4 outcomes that can happen. Now we're going to work through a couple of these, and then we'll move on to the next section. This is a very short section. There's not very many of them. Most of them are very easy to do. I'm going to pick one from our textbook to look at. I think I'll just grab one from our textbook here. These are called compound inequalities. We are in 1-6. So let's look here at a couple of these. I'll do at least one. Maybe if we need to, we'll do two of them. Let's look at page 122. We will look at question 46. And I'll write it up in case we don't have our textbook, but this is what we've got here. Now, we've done these before, right? But this one's going to require us to do a little bit of algebra first. So we're going to have to solve each of these for the inequality. So we do each one separately, and then we'll put them back together with that or. So the first one, easy enough. We're going to move that 2 over. And then we have 3x is less than or equal to -9. We'll divide by our 3. And now we've got x being less than or equal to, when we reduce, -3. So that's that first one. What about the other one? The other one, we subtract off our 1. So we've got a -2x is less than or equal to +8. We'll divide by our -2. Now, are we going to switch our inequality symbol? Yes or no? Are we going to switch our inequality symbol? We will. Why are we going to switch our inequality symbol? Because we are dividing by a negative, right? When you divide by a negative, that flips the symbol around. So we flip that around. And 8 divided by a -2, well, that is a -4. Now we're going to put these on the number line. So let's go ahead now and put these on our number line. And then we'll work with the or. So this is what we've got. I mean, what's in between them? An or. So we're going to put these on the number line. Make sure you put them in the correct order here. So our number line is down here. We want a -3, and we'll do it first. And which way is it pointing? -3, it's here, it's pointing to the left. It gets a square bracket, so this one we'll do in blue. So there is it. Okay. Now, what about the -4? Well, -4 is smaller, so it's further behind. So there's our -4. We're going to do it in green. And which way is it pointing? It is pointing to the right. So that's where we shade. We shade to the right. So that's what our picture looks like. Now, what do we want? We want or. And or, what does that mean? That means it's a union. And we combine it all together. So we're going to combine these graphs. So if I combine the graphs, what does it look like? If I combine the graphs, there's no empty space. So if I combine those graphs, it would look like what? Negative to positive infinity, wouldn't it? Is everyone okay with how I did that? Now, if it was an and, what would the and be? If this would have been an and, it would be this part right here, okay? Because and means where they overlap. Or, is combining them together. So and is an overlap, or is where we combine them together. Let's do one more of these, and then I'll talk about question 10. So one more of these. Again, we'll be on page 122 again, I believe. And let's do an and. But we look at, how about question 62? So this again is going to be on page 122. And we're going to look now at question 62. So this is what we've got here. Now, what's the difference between this one and the last one? Well, on the last one, that was an or. And what did or mean? Or means we combine them together. What does and mean? And means it's an intersection, and we are going to be looking at where they overlap, what they have in common. So we're going to work both of these out, and then we'll put the and in between them. So let's begin by moving things around. So I'm going to try to add that 6 over to each side on the left. So that gives me a 2x is now less than or equal to negative 18 plus 6. That's a negative 12. We'll divide by our 2. Do we switch our inequality symbol, yes or no? No. Why not? We divided by a positive 2, so it stays the same at that negative 6. What about the other one? We divide by our 2. Do we flip it around? No. So it stays the same, and that is now x is greater than or equal to negative 18 over 2. Okay, if we look at that one, negative 18 over 2. That's going to reduce down, isn't it? Right? Because negative 18 over 2, well, that's a negative what? 9, right? Okay. Now, what do we have in between them? We have an and. So we're going to graph these out, and we're going to look at what they have in common, where they overlap. So this first one is x is less than or equal to a negative 6. So the negative 6, we'll put that over here somewhere, and it is pointing to the left, so that is where we shade with the square bracket back to the left, just like that. What about the other one? Negative 9 is here, and this one is pointing to the right, so we use a square bracket, and it's going there. Now, what's in between them? An and. And what does and mean? And means intersection, and that means where they overlap, what they have in common. And what do they have in common? Where they overlap at? They overlap right here in the middle. So what would that look like now in interval notation? Well, that would be negative 9 with the square bracket, comma, negative 6, also with what? Also with the square bracket. So is everyone okay with how we did that? Now, I'm going to set up and do part of question 10. I'm only going to do the first part of it. So for question 10, we're going to have to know how to find the area and the perimeter of the room. So each of the 6 decorators has to paint a room with the walls only, and then they're going to put a wallpaper border around the room at the ceiling. 1 gallon of paint covers 400 square feet, and 1 roll of border contains 5 yards. Each decorator has 1 gallon of paint, and they have 3 rolls of border. So the first thing we need to do is figure out what we have to work with. We have yards, which we're going to turn those yards into feet. And then we have the square feet for the area. Now, what do we want? Here's our decorators, and we want to determine who will have either enough to paint or border or both. So they have to either be able to paint the room, border it, or they can do both of them. I'm going to do the first one for you. I'm going to do Jane. Now, let's talk about our paint. When we have 1 gallon of paint, which is the same for all of these, 1 gallon covers that 400 square feet. So that's an area. So we'll talk about that one first. So 1 gallon, 400 square feet. Square feet means it's an area. Now, what about the border? We have 3 rolls of border. And each roll has 5 yards. So let's see what we have in terms of feet. So 5 yards each. What would that be in terms of feet? Because we need to make sure we get the correct units. Remember, there are 3 feet in a yard, right? So 3 feet in a yard. So that means we have 5 times 3, which is then 15. Okay, so 15 feet for each roll of paper. Now, how many rolls of paper do we have? We have 3. So 3 rolls of that border. So 3 rolls of border would be 15 times 3, which is then 45 feet. Remember, there's 3 feet in a yard. So these are the 2 important parts that we have. We have the area and we have the perimeter. A lot of you probably aren't used to using English units, but we do use feet and yards, and there's 3 feet in a yard. So we always go to the common unit. Everything else is in terms of feet, so we're going to be using feet. Now, let's look at the first decorator. For each of these, we're going to have to find out if they have enough to paint, if they can decorate, or if they can do both of these. I'm going to look at Jane. So Jane's room is 9 by 12 feet. Everything's in the common unit of feet. So what does Jane's room look like? Well, Jane's room looks like this. And it also tells us that this room has a standard height of 8 feet. So it's 9 by 12. So it's going to look like that. That's her room. 3 dimensions. It's a rectangular solid. Okay, it's 8-foot tall ceilings, because this is your ceiling. And it's 9 by 12. Now let's first find that area of the walls. How many walls do we have? If I'm going to paint this, how many walls do I have to paint? Think about this room. You've got 1, 2, 3, 4 walls, right? So whatever we get, we're going to have to make sure we get all 4 of them. 2 walls are the same, left and right. Front and back are the same. So let's look at the front and back. It's here and here. So the front and the back wall looks like this, and I'll move it up so we can see it in just a moment here. Okay, so this is what we've got. We've got our picture for Jane. We've got a front and a back. So we're going to have to do this twice because you have two of them. Now, I want to paint this room. This is an area. I'm going to paint this wall, right? And what would that be? Okay, for the front and the back, it's an 8 by 9, right? And what else do we have to do with it? Multiply it by what? 2, because there's a front and there's a back wall. So we have a front and a back. That means we've got to multiply it by 2. So how many square feet would that be? Right? That's 8 times 9 times 2. So that gives you 144 square feet. So that's part of it. Now, what about the left and the right wall? Left and the right wall. There's your left and your right wall here. And this is 12 by 8, right? So this is 12 by 8 here. Okay, now we have to have 2 of these. Why do we have 2 of these? Because we have a left and a right. And so what would this area be? This area would be 8 times 12 times 2, which is then 8 times 12 times 2. Looks like that's 192 square feet. And what's the total area now? My total area is 144 plus 192, which is then 336 square feet. Now, it needs to be less than 400 because we want to paint it with 1 gallon of paint. So is it less than 400 square feet? Yes, it is. Okay, so that means that one would be a yes. Now, how do we paper it? Okay, so this one's already done because we want to know which of the decorators can either paint it, wallpaper it, or do both. So this person we already know can paint it, right? Because we have a gallon of paint, it covers 400. That area is only 336, so it works. Now, what about the paper, the wallpaper border? Again, we're going to do the same concept here with the wallpaper border. So we're going to look at the left and the right first. Well, either one. You do the left or right, top or bottom, doesn't matter. But let's do the left and the right first. We'll do the top and the bottom next. Okay, so how do we paper? How do we paper a room? Well, if we want to paper this border, okay, what does that look like? The wallpaper border is going to be right along the top, isn't it? And we need 2 of them because we have a left and a right again. And this is 8 feet by 12. Now, if I want to paper this, we're adding it up. Paper is like the perimeter. So we're going to add these up. We've got a left and a right side. That's why we have 2 of them. So what would this be if I were to paper it? It would be 12 times 2 because we have 2 sides. We don't care about the height because all we're doing is putting paper up. Right? We're going to unroll it. That's the perimeter. So 12 times 2, that's 24 feet. What about, and this is the border here, border paper. Okay. What about the top and the bottom? When I look at my diagram, what about that? That's going to be this, okay? Top and bottom, left and right. We already did the left and the right. Let's look at the top and the bottom here. So it's going to look like this. Again, 9 feet long, 8 foot tall ceilings. If we're going to paper this, we don't care about the height of the ceiling because all we have to do is put the wallpaper border up. We again need 2 of these. So putting those together, that's going to be, it's 9 feet long, 9 times 2, which is then 18 feet. What is my total amount of border paper that I need? Okay, total border is going to equal 24 plus that 18 feet. And when we put those together, 24 and 18, that gives you 42 feet. Now, can we paper it? Yes, we can paper it. Why can we paper it? Because is it less than that 45 feet? Yes, it is, right? Or not square feet, just 45 feet there. So yes, it is. So what am I looking for? Let's go back and talk about what I want now. So you see how I papered it, right? How you put that wallpaper border up, and also how you paint the room, right? We have 1 gallon of paint, 3 rolls of border. So we can do 45 feet of wallpaper, and we can do 400 square feet for the area. Now, what do I want you to do? I want you to go through and do each one of these. So I did Jane. Now, what do we want? We want to know the decorators who can either paint it, or border it, or both. So what do we know about Jane? Can Jane paper the room? Yes. Can Jane put border on the room? Yes. So Jane would be yes. And you list all the others out. Okay. John, you'll do the same procedure. Now, if it's a yes for either one of them, that means he can do it. He or she can do it. So if both of them come out to be no, you don't write the name down. If they come out to be a yes at all, you'll write it down. So you'll do John the same way. His room is 10 by 12. So it is a little bit bigger. Right? Still 8 foot tall ceilings. So you'll want to finish this one out. I did Jane for you. Okay? And Jane can paper and Jane can walk and paint that room. So it's yes for both. So it works. You do each of the others. You have to do John, Norco, Sergey, Consuela, and Manuel. You have to do them all. Okay? And you figure out which ones can either paint it, border it, or both. That now takes care of 1.6. We're going to move on now and look at 1.7. And we may not finish all of 1.7 today. Whatever we don't finish today, we'll finish on Tuesday. We should be able to at least get through the absolute value equalities. And no problem. You've probably seen these before, but we're going to be talking about absolute values. Sure. Sorry about that.
No, you're fine. On that last one,
Sure.
Specify what they can do.
Yeah, just list them out. But what I would do is I would just make kind of a table like this, and this is going to be the paint, border, and I would just do each one. So we did Jane, and so Jane can paint the room, Jane can border the room, so that would be a yes there. And I would do the next one the same way, and I would see if they get a check mark in either of the boxes, that means they can do it. But does it make sense how we figured that out? And that's a real-world application, because when you paint a room, you need to figure out how many gallons of paint I have. Okay, and it's pretty accurate. It'll tell you how much it has in there. And when you paint a room, you don't worry about the walls, or the windows and the doors, because that's extra, and that kind of makes sure you don't run out. So when you paint a room, you just figure out how much it's going to be compared to the amount on the can, and that should be pretty close. And that'll tell you if I need to get another can or not, because you don't want to run out of paint in the middle of a project. Border, you just measure around, right, around the room, add it up, and that tells you how much paper you're going to need. But you'll do each one the same way, and if it has a check mark in either of the boxes, then that person can do it. Does that make sense now? Okay, yep, sorry about that. So that's what I'm wanting, is just list the names out, and you can just make a chart and check them off as you go. 1.7, we're going to be talking about absolute values. And you probably talked about absolute values before. And what do we know about absolute values? Let's just review absolute values again, just so we remember. These are called absolute value bars. Absolute value bars, that's what they're called. And what happens when I take the absolute value of a number? Let's see what happens when you take these absolute values. What about the absolute value of 9? What would the absolute value of 9 be? Does anyone know? This is simple enough here. Absolute value of 9 is going to be what? 9, right? Because what does an absolute value do? Just so we remember, absolute value takes it and makes it positive. And if it's already positive, it just stays positive. The only exception is 0, because the absolute value of 0 is 0. So absolute value of 9 is 9. What about the absolute value of negative 3? Well, the absolute value of negative 3, would that be positive 3 or would that be negative 3? Positive 3. Okay. And what's the absolute value of 0? Well, the absolute value of 0 is still what? 0. Okay. Now, look at these two. I want you to see this correlation here. Absolute value of 3 is 3, and also absolute value of negative 3 is also what? 3. They give you the same number, don't they? So when we look at these absolute values, we're going to have to get two answers, because you can have a positive answer and a negative answer. So let's try to talk through and discuss this one. Absolute value of x equals, how about 10? What two numbers would work here? What two numbers can give you an absolute value of 10 just by looking at it? Well, x could be 10, right? Because what's the absolute value of 10? 10. What could x also be? Does anyone know? It could be a negative 10, right? Because the absolute value of negative 10 is what? Positive 10, and that's what we want. So we get on these two answers. Now that one we could just look at and see. What happens if there's extra things in it? What happens if I say solve 2x plus 5 equals 10? Now we need to get two answers. All right, when we solve these, we've got to get the two answers. To get the two answers, we get two equations. So what are our two equations going to look like? Well, one of them you just drop the absolute value bars. So that's 2x plus 5 equals 10. That's one of them. Or, it's going to be the other one, 2x plus 5 equals a negative 10. You probably remember that from other courses, right? You're going to get two answers on these. Solve it out. So move that 5 over. 2x equals now 5, it looks like. Divide by your 2. So one solution is 5/2. So there's one of them. What about the other one? The other one, move that 5 over. So that is now 2x equals a negative 15. divide by your 2, and so x now equals a negative 15 over what? 2. So there's your 2 answers. So on these, you're going to get 2. Unless it's 0, and then you just get 1. But in most of these, you're going to get 2 answers. Right? And they can both be positive, both be negative. Either one. So don't think you just did it wrong because they both come out to be positive numbers. That can happen. That can happen where they're both positive. A lot of times, though, one will be positive, one will be negative. Let's do a few more. We've got a few more minutes here, so we'll do a couple more of these. Next time, we'll do the inequalities. So this one's a little bit different here. Now, whenever we solve these absolute values, I always like to make these larger so you see these are absolute values. You have to make sure the absolute value is by itself on the left. So the absolute value must be alone on the left. So I need to make sure that that absolute value is alone on the left, by itself. So that means that 9 needs to go over to the right-hand side. So that absolute value has to be by itself on the left. So move that over first. And that gives you now 11. So that's the first thing that we did, is you have to make sure that that absolute value is isolated by itself. Now we build our 2 equations. Never ever change what's inside the absolute values. We keep that the same. The only part that ever gets changed is the right-hand side, so that number. So we have a negative 7x plus 4 equals 11, or a negative 7x plus 4 equals a negative 11. So you have a positive 1 and you have a negative 1. Solve it just like we did a moment ago. So move that 4 over. So minus 7x equals now 11 minus 4. Well, that looks like a positive 7, isn't it? We'll divide now by our negative 7. And what does one of them come out to be? Looks like one of my solutions is x equals a negative 1. So that's easy enough there. All right, we still need to get the other one. So we're going to move that 4 over. And the other one is a minus 7x equals minus 15. We'll divide by our minus 7. Negative over negative makes it a positive. So that's going to be a positive 15 for 7. And we've got both answers. Let's do another one. Let's talk about 0. So let's try to solve this one. We're going to try and solve them. That's what we're doing here. Let's try and solve 2x minus 5 equals 0. If I give you 2x minus 5 equals 0, I'm only going to get one solution. Why? Because 0 doesn't have a sign with it. So the only equation that I can get when I drop the absolute value bars is going to be 2x minus 5 equals 0. Right? That's it. Because there's no positive and negative, because the right-hand side is 0. So only one solution. Now, we can finish this out by adding that 5 over. And now we've got 2x equals 5. We'll divide by our 2. And so our only solution is 5 over 2. So only one solution. Why do we only get one solution? Because of the 0. You can also have no solution. And how can you have no solution? Well, you can have no solution because that's going to be a contradiction, and that's something that can't happen. So let's look at these three. I'll do 3 of them, just so we make sure we understand why these have no solution. Okay, we just have to think about absolute values. What comes out of an absolute value every single time? What's the absolute value of 10? Positive 10. What's the absolute value of negative 9? Positive 9. What's the absolute value of negative 4? Positive 4. Can we ever have an absolute value that gives you a negative 6? Can that ever happen? No. So this is negative. So since it is negative, it has no solution. So it has no solution. You have to be careful and don't jump to conclusions and think that you get a solution. Like this one is also going to have no solution. Now you might look at this one and you might think that it has a solution. Right, but what's our procedure? Our procedure before we do anything else is make sure that that absolute value, all right, is by itself on the left. So before I can draw any conclusions, I need to move that 9 over. So let's go ahead now and move that 9 over with subtraction. And when I move that 9 over with subtraction, that leaves you with this. So 7 minus 9, that leaves you with a negative 2. Well, that's negative again. And since that is negative, it has no solution. So no solution there. Why does it have no solution? No solution because it is what? Negative on that right-hand side. It's negative on the right-hand side. When we move things around, it has no solution. One more, and then we'll talk about an absolute value equaling another absolute value. So we're almost done. A couple more questions and we'll be done for the day. Well, let's do another one just to make sure. We've talked about this many, many times. Absolute value of, let's say, 2/3 x plus 1/7 is going to equal a minus 5/3. Now, I guarantee that someone is going to try and solve this out. Okay? Do we even need to solve this out at all? Is there anything that we need to do? No. Why not? We don't have to do anything else because this is what? Negative on the right-hand side. So do we have to clear the fractions? Do we have to do any of that? No. Okay. Again, since this is negative, it has no solution. But someone is going to try and solve it. And you don't do that because this is negative. It has no solution. Okay, so just be aware of that. If it's negative on the right-hand side after you've moved things around, it has no solution. We need to cover one more quick topic, and that's what happens when we have an absolute value equaling another absolute value. And this is easy as well. And we'll do two of these because these are pretty easy, pretty straightforward. So this is what we've got. Okay, I want you to solve this. Now, what do we know about absolute values? When I go to solve an absolute value, all right, I'm going to get two equations. So I've got to get two equations out of this. So the first equation, all I do is I drop the absolute value bars. So my first equation is simply going to be 5x plus 2 equals 4x plus 9. And what's my other one going to be? Well, I changed the signs on the right. So on the other equation is going to be 5x plus 2 equals, you put a negative in front, use parentheses, 4x plus 9. Okay? Let me change the right-hand side. So the first equation stays exactly the same. All you do is you drop the absolute value bars. The second equation, we look at the right-hand side and we put a negative in front. And now we just solve each of these out. So we've got to distribute the negative through on this one and solve the other one. And I like to split it down the middle to make it easier to see. We'll quickly work this one out. We'll do this one and then one more. So I'm going to work on the left one first. So I'm going to move that 2 over. And I'm going to move that 4x over. You can do two things at once. 5x minus 4x, that leaves you with a single x. 2's cancel. 4x's cancel. And 9 minus 2, well, 9 minus 2 is a 7. So there's that one. What about the other one? Well, the other one, we distribute that negative through. So that's 5x plus 2 equals, we have a minus 4x and a minus 9. Right, distribute it through. Notice I drew the arrows and I pushed it through each one. A lot of times students forget to do the second part. They'll forget to do the 9. So make sure you distribute it through both parts. Now we can finish it. So I'm going to add the 4x over now, in this case. And I'm going to take away the 2. So 5 and 4 makes it 9x. The 2's again cancel. 4x's cancel. And minus 9 minus 2, well, that is a minus 11. We'll divide by our 9. And what's my second answer going to be? Looks like x equals now 11 ninths. So we have two solutions because this is an absolute value. Okay. We'll do one more. So I'm going to go ahead and pass out the sign-in sheet. Pass out the sign-in sheet here. And then if you've turned in homework and haven't picked it up yet, have it all up here as well. So before you leave today, if you want to pick up your old homework, I'll put it over here. If you've got homework to turn in, I'll take that today as well. You should hopefully have done 1.4. If you want to turn it in on Tuesday, you can do that. But again, please try not to fall too far behind. So let's do one more, and this will be our last question here. And I wanted to do one with fractions, just so we, again, review fractions. So this will be our last one. First off, what do my two equations look like? Well, they look like 2/3 x plus 5 equals a minus 4/9 x plus 1. And then we have an or. other one is 2/3 x plus 5 equals, now make sure you put the negative in front, parentheses, make sure you use the parentheses here, minus 4/9 x plus 1. Okay, so don't try to make this harder than it needs to be. The fractions are going to be easy to clear out. Does anyone know what I need to multiply this by to get rid of my fractions here? Anyone want to take a guess? What would I use? What number to clear out my fractions here? If I said solve this, what would you use? I'm going to clear out your fractions. Okay, what do we have for my denominators? 3, and we have a what? 9, right? What's the least common denominator of 3 and 9? Well, that would be a 9, right? So we're going to multiply it all by what? 9. Remember how to clear the fractions? Each piece gets it. So multiply it through. 9 divided by 3. 9 divided by 3 is 3 times 2 makes it the 6x there. 9 times 5 is your 45. 9's cancel. That leaves you with a minus 4x. And 9 times 1, that's a 9. Now we can easily and quickly finish it here. So I'm going to add that 4x over and subtract off that 45. So 6 and 4 makes it 10x. The 45s are gone. 4x's are gone. And 9 minus 45, 9 minus 45 should be a what? 36, isn't it? Right? 9 minus 45 gives you that 36. And it's a negative. We'll divide by our 10. Always make sure you reduce. These are both even numbers, so I know I can at least use it 2. So that's going to reduce down now to be a negative 18 over 5. Okay. For the other one, what do we do first? First thing we do is distribute that negative through. That's going to change the signs. And that's going to make it 2/3 x plus 5 equals negative and negative makes it positive 4/9 x. Positive and negative makes it a negative 1. Just like we did a moment ago, we're going to multiply all of this by 9. Okay, that's going to clear out my fractions. 9 divided by 3 is 3 times 2 makes it a 6x again. 9 times 5 is 45. The 9's cancel. That leaves you with a 4x. And 9 times a negative 1, well, that is a what? Negative 9. We'll finish this out. So move that 4x over. And also move that 45. So combining 6 minus 4, that leaves you with a positive 2x if we combine those together. Negative 9 and negative 45, those go together. And that's going to make it a 54, negative, right? So it's negative 54 there. Divide by our 2. And that gives me now, x is going to equal a negative 27. Can both of these answers be negative? Yes, they can. So don't ever think that my answers both came out to be negative. I made a mistake. They can both be negative. They can both be positive. Most of the time, though, one will be positive, one will be negative. But if they're both negative, that's okay. That doesn't mean you solved it incorrectly. That's okay. That can happen. So these are both answers that you could have. So go ahead and make sure you sign that sign-in sheet then, and I will see everyone then on Tuesday. And let's talk about our homework real quick before we leave. So your homework. So what did we cover today for our homework? We covered 1.6. You can do them all. Right? So you can do all of 1.6. 1-7. Let's talk about which ones you can do here. For 1-7, you can do a few of these. You can do question 5. That's an equal sign. You can do question 6. We'll talk about 8 next time. You can do 9. You can do 10. Can't do 11 yet. We'll talk about 12 next time. You can do 15, because that's a fraction one. You can do 16, 17, and 20. So those are the ones that you can do. And what do you want to turn in next time? Well, next time you want to turn in, should be, if you're keeping up with the course, you should be ready to turn in next class period 1-5, right? So make sure for next class period that you've got 1-5 done. If you've got homework, I'll take it. If you want to turn things in next time, you can do that too. Just again, be very careful about falling behind. Okay, do we have some? Do you have a question?